The sustainability of a water well and the length of its operation time can be influenced positively already by proper planning and dimensioning, which leads to higher yield, slower aging, and easier rehabilitation. Hydrochemically difficult areas with high aging potential should be avoided in the first place, and groundwaters of different types along the screen are not to be mixed. Furthermore, the drilling and casing radii should be adjusted to the maximum permissible entrance velocity, and the width of screen slots and the grain size correspond to aquifer characteristics. The selection of construction materials is also paramount, influencing the sustainability, as higher investments usually mean better performance. Wire-wound screens with their large free inlet surfaces are particularly easy for accessing the colmated annular space and the geological formation beyond it. On the contrary, screens covered with pre-glued gravel or mesh are problematic due to their limited pore space, hindering the access towards the borehole wall. When comparing alternative materials, future production costs, including electrical power and regular maintenance, should be taken into account in any case. False savings during construction and development of the well do not pay off in the long run. Also, the mode of operation of a well has a crucial influence on its lifespan and on the maintenance intervals. A full assessment of your well's performance provides the necessary data for later comparison. In the ideal case, the pumping capacity and time are oriented towards the yield and the constructional characteristics of the well, and the production takes place continuously without frequent on and off switching. The dynamic water level is not lowered down to the screen area, and the entrance velocity is kept low. Maintenance includes continuous monitoring, regular inspections, and made-to-measure service plans for each individual well to minimize aging processes and to secure a steady production. Inspections collect and verify data visually, manually, and acoustically of the current performance, drawdown, and structural condition. The evaluation of the collected data provides the basis of required service and maintenance. Track your well's performance on a regular basis by step discharge test, flow meter, camera inspection, and geophysics. It enables the timely execution of rehabilitation, repair and reconstruction measures, and also the verification of the achieved targets. Already a yield decrease of 10% can be a sign of an advanced stage of well aging, and this should trigger a fact-finding mission for its cause. The mineralogy of an incrustation has a considerable influence on its reliability. Visible layers like annual rings prove that well aging is a continuous phenomenon. For the practice, it means that the aging of wells and their incrustations should be interrupted at the earliest possible stage when deposits consist of easily soluble mineral phases. However, just as much as an early removal of iron and manganese oxides contributes to sustainability, the thoroughness of the removal does due to their autocatalytic effect. Autocatalysis of iron and manganese oxides means simply that in case the deposits have not been removed thoroughly and their surface areas in the pore channels are larger after the rehab than before, they function as a catalyst and accelerate the growth of clogging exponentially. In the worst case, an incomplete rehabilitation speeds up natural well aging instead of slowing it down. Know your enemy. What is the cause of any observed aging? Incrustations, corrosion, or particles? If the yield has decreased by 20% of the original value, do rehabilitate and kill it before it grows.